everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're talking about issues in the back end and sharing insights on recent disruptions at Slack, Microsoft 365, Otter, and Grafana Cloud. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Let's get started with the issue over at Slack. I asked Mike to explain what he saw there.
It's on February 26th, and it kind of began around 3 p.m. UTC, or that's when we first observed it, which was around 7 a.m. PST, so Pacific time. And that's important because that's the start of the business day for these people. What we actually detected was this service disruption there, and it started off as this timeout. So we could actually reach the network, we could actually get to the Slack service, and then we started seeing these sort of 500 server errors. It started off in reasonably small. So I was actually online at the time, and I was actually using Slack, and people were telling me that it was down. They couldn't use Slack. They switched to an alternate system, but I could still work. And then it actually started to spread, and we saw it spread right across the globe till it then became sort of this global issue. And it actually lasted for around 9 hours in terms of total disruption.
With a service such as Slack, most users will access it via an app rather than a web interface that might display telltale error messages. So what are the signals you're looking for when trying to diagnose a problem with a service such as Slack?
So a couple of things. What we're looking for is we're always looking for commonality. So Slack can be entered through different ways. So I can actually go through for a mobile client. I can actually do through a thick client on my desktop, an application. And you can actually access it through a web browser. Now, ultimately, they're using sort of common architecture in the back end, even though their access points may be different. So we're looking for these systems. So the first thing you did, in fact, the first thing I did was when it started to go down, I flipped to my mobile phone to actually see whether it was actually the client itself was still running on that. So again, we're coming back for these signals. So we're looking for this commonality. We can see that we've got the network connectivity. So we're actually getting to the front door. I can see I'm getting to different servers around the place. The fact then we're having this global issue then sort of indicates I'm looking at something within the application itself. Now, is it within the infrastructure, within a region, or is it with something more fundamental within the application? So if we sort of take a little step back from there, so we can actually get onto the system, I can actually load sort of the front page. So again, we know my network integrity is fine. We can start to get connectivity. The fact then it was across all three platforms, all three modes I could get there, I think I'm looking at some sort of common problem with the application itself. Then I want to look for the signals I'm getting back. So if I actually look for the signals I'm getting back, we said we saw a HTTP 500 error returned. And that was a request not for authentication. That's a request to actually retrieve information. So the problem manifested itself in this inability to send messages or pull down new messages. So what happened was it actually just went and said, unable to send message, try again later with the error message on the screen there. We know for 500 error is a server-side error. So it's being served from the retrieval of information there. And 500 is normally a catch-all. So the developers can actually sort of use the 500, 501, 502, 503. There is categories they'll place them in, and it gives indication. But 500 is normally this catch-all. But what it actually indicates is internal server error. When we actually go into that, we then start to look at the characteristics. We can actually get to the system, we could get across there, and then we start to trust that this is a 500 error. What are we actually trying to call back in the system itself? We're actually trying to retrieve information from a set of distributed databases. So Slack use horizontal partitioning to sort of speed up the retrieval of information. So we're trying to get information. We're seeing this 500. We know it's in the back-end service because we've got the network connectivity. So then we're looking to say, what can we tie together with the architecture and the signal itself? In this case, for the 500. So we sort of indicate that then it was going to be something potentially within that database. Now, we're able to sort of then verify that later on because Slack actually came out and said in some of their restoration services, they were bringing this service back online. They talked about rebuilding some of the shard partitioning, some of the horizontal partitioning, as well as rebuilding the replica databases that sort of build it up, which validated what we'd saw and been able to sort of confirm with his back end there. So it's a combination of putting those signals together, gives you an indication, first of all, where that fault domain is. Is it on my client? Is it unique to a particular desktop client, mobile client, or a web browser? And then you sort of step that back. Is that where the fault lies? Does the fault lie within the network? Does it lie within my local environment? Is it with the CDN? Is it with the application itself? Or was it the architecture of the infrastructure of the application?
Users who were still logged into Slack at the time of the incident could potentially view past conversations, but may have had issues sending and receiving new messages. Is this a case where local cache may mask an issue, and why it's important to always look at all the signals?
Yeah, you always look at things in context. So it wasn't necessarily sort of cache. It depended on what platform you're actually looking on. So if I could actually authenticate to the browser and I couldn't pull information down, right? So I wasn't getting there. It was only if I was on a desktop client itself or with on the mobile client, I could get those messages there. So yeah, that's a little bit of sort of caching. I've actually stored that information there. But it would have been quite quick to see, straight away, if you sort of do a refresh, nothing would have come in. And it would actually, then it goes, the status would immediately change to offline, can't retrieve messages. But absolutely, you're looking for these indications. Nobody's going to be under any illusion that the application, it was up, they could log on, and it was actually functioning correctly. Because as soon as I said they started to refresh, or the status would go out there. But you need to look at all these signals in context, as we said, which comes back to identifying my fault domain, first of all. And when I've identified where my fault domain is, let's go down to the specifics within there, see where you can actually solve that most probable cause. And the reason you do that is because you then have to sort of put in, what plan do I need to action to get out of this situation? As we said, this was going on for a long time once we started to see it, and we communicate over Slack. So what we had to do was switch to an alternate messaging system so we could maintain that communication while we actually went through and troubleshot what was going on there. It may have been that you say, okay, if it happened to be with specifically with the mobile client, okay, what you need to do is to go to the web browser or go to the thick client. There's all these different ways. So it's not just identifying where that fault is, it's also taking that so you can action it, so you can take steps to mitigate it and remediate the problem.
On March the 1st, thousands of Microsoft 365 customers reported experiencing problems with various services, including Outlook. What appears to have happened here, Mike?
Again, what we actually saw when we looked at this, we could see the network connectivity from every region was intact. So straight away, we know, we don't know, we assume we're actually looking at some sort of application side issue, so some back-end server. The other thing then, Microsoft sort of came out quite quickly and said that there was this issue impacting multiple services, which included Outlook, but also some of their team's information. So again, this is coming back to this commonality aspect. From a regional perspective, so it sort of hit us here down in Australia on Sunday morning. And the first thing I noticed was that I'd actually got a request to re-authenticate on my mobile client. So it actually came up to sort of re-authenticate, which again sort of gave me a clue, a signal to there. And when we actually went and looked in a test, again, we could see we could get to the front door, but it wouldn't go beyond there. So anything was actually looking to authenticate was having a problem. Wasn't necessarily to say that it is with the authentication process itself, but this was the stopping point. So therefore, it's a back-end service. It's common across different Microsoft services themselves, and there was some sort of link in it. Maybe it couldn't reach it. There were some reports of 500 errors, as we were saying before. So again, indicating we had some sort of back-end issue. Microsoft actually came out and said it was due to a code change they'd done, and they rolled back the change, and that rectified the problem. I will say then sort of 24 hours later, I did get the same re-authenticate message come back on my mobile client, but this time it went straight in. So I should probably say that when I actually did try to re-authenticate when the mobile client came up, it would just simply go back and ask you again and again as if it was in some sort of loop, which meant that wasn't getting through. So I couldn't actually get that, it couldn't verify the authentication. So that's what I'm saying. The second time, and they just rolled back that change back. So the second time when it happened 24 hours later, when it asked me to authenticate, I went in and straight away it was able to reaffirm it and authenticate it and everything went across there. So we see this on occasions. We've talked about this in the past where we sort of see these London buses come along 3 at a time where a change takes place. They either have this approach where they can actually fix it or they can effectively sort of roll it back and then attempt it later on. And this is what it kind of looked like was happening here.
Soon after Microsoft acknowledged this issue, it said it was reviewing available telemetry and customer-provided logs to understand the impact. Having access to such a vast pool of customer data must be a significant advantage in situations like these.
It is. They can actually look at it from there. And this is coming back to this understanding what's happening. You've got to do this stuff at scale. So we always talk about having the messages in context. If I've got one user reporting a problem, it looks like it may be down to one person. But if I can actually go in and understand what's happening across multiple signals, multiple areas, what does it look in different conditions? This is coming back to looking for that commonality. So once I found the commonality, they knew the change they'd done. But obviously they put this change in not expecting it to go wrong or to cause this sort of disruption. So therefore, then what we need to do is we need to go back and look for the evidence. But you can apply this across every application or from your own applications. If you can actually sort of have a broad perspective of what's happening, as we talked about with the Slack outage, is it impacting this particular client? Is it impacting the mobile client? Is it impacting the desktop client? And then get to that point of commonality. The more data points you've got, always in context. So remember, you've got to have that in context to sort of bring that data in. Then absolutely you can understand what's happening and then guard against this type of thing happening a second time.
In some ways, it was fortunate that this incident happened on a weekend, meaning the impact of the outage was perhaps less than it might have been. But is it also possibly deliberate that Microsoft's pushing a big change out at the weekend just in case something goes wrong?
Yeah, it could indicate that. And again, they came out and said they did a code change, which they rolled back. But absolutely, let's push changes. We don't expect them to cause damage, but if they do, then we're doing it in a window where we have less of an impact to our business users, to our main customers. And in theory, we can rectify it quicker without causing too much damage or having too much of a disruption or too much of an impact. Historically, if we look at the ISPs or the telcos, and say my age here, we worked in these environments, you have change windows, and these change windows are always outside your business hours. So when we get into this world where we're 24/7, we have a global economy, then where are those change windows? I can't necessarily do it at just 2 a.m. because 2 a.m. in North America is 2 p.m. for Asia Pac or Australia. So you need to be able to sort of do the least impactful time, which in this case was late Saturday night, US East time or US time, which then sort of rolled down where we sort of saw it on a Sunday morning here in Asia Pac.
Meeting assistant Otter experienced incidents in late February. What did you see this time, Mike?
I actually had a couple of instances. Again, what we actually saw here was we could actually get to the front door, but it actually impacted users' ability to interact with the system. So again, get there, network integrity is good, but during the disruptions, the users sort of encountered HTTP 502 bad gateway errors they saw in their browser, and a few of them actually saw 500 internal server errors. Now, this is a case where the 500s they were sort of manifest themselves within the portal itself, so within the browser coming back. The predominant error we're seeing with these 502 bad gateway errors, which sort of indicates then, again, we're having trouble in terms of routing to our back-end system. But rather than the problem with the application itself, this seemed to impact the ability to authenticate, but the process as opposed to that system. So I just couldn't get to the right server. And we sort of saw some of these redirects and then redirects timing out. And as I said, these bad gateways where we couldn't actually get to that network perspective.
This is why you often say rolling back isn't really a fix, because the maintenance will still have to be attempted again sometime in the future, right?
Yeah, again, this happened. We had these sort of 2 different times across there. It was attempted outside of peak hours. Again, it impacted more the APAC zone, but it was just from the time of day there. It depends on how soon you catch the issue. So I said, nobody implements a code change or some sort of maintenance change or upgrade expecting to be destructive, expected to cause a disruption to the people. But if we're too far into that process, you can't always roll it back. So you can do a couple of things. You can actually either just stop the process or try to implement a fix. Or said, if you haven't gone too far, and it is easily rolled back. If I'm actually changing complete systems there, or I'm changing stuff and I'm distributing these patches across the world, I might have got too far before I've realized that problem and can't roll it back. So in that place, I have to put a mitigation or workaround in place, and then I have to attempt the fix. When I roll it back, it's somewhat easier. I roll it back, everything returns to normal. It was a working state before. If I haven't gone too far and I can actually roll it back, everything goes back to a normal state, the state it was prior to the change. Before we had that issue, we've identified it was a change that caused a problem, and then we go back to that state. So then I can actually work out, which is thinking about looking at those log files that we did from a Microsoft perspective, I can understand what went on, why did that change cause that issue, and then I can make it and then I can re-implement the change. Whereas if I've actually gone too far and I can't roll it back, I have to put a workaround in place, and then I have to implement it again. And this is sometimes where we see sort of the 2 or the 3, as opposed to sort of just 2 occurrences happening.
Grafana Cloud experienced degraded performance for multiple days, starting on February 24th. What caused this one, Mike?
So it impacted a subset of users, and it was actually degraded performance. So it was actually slow, and they couldn't actually spin up new instances. The interesting thing about this, it was only actually impacting AWS environments. So if we actually look at Grafana status page, you can see where they've got instances hosted in Azure and GCP. They're showing green, but it's just every region within AWS. It actually looked like it was some specific US regions were impacted more, but it was just across there. So this then comes back again to, we're not looking at an application-wide issue. We're not looking at a network issue. We're not looking even at a cloud provider issue. We're looking at one specific function that is unique specifically to the interaction between Grafana and the hosted instances there. May have been spinning them up, may have been the orchestration process. They haven't actually come out with anything at that point there. But the point is, you've identified that problem domain.
The Grafana status page showed only the AWS hosted environments were experiencing problems, as you said. In such cases, would you also be checking AWS's status page to check if it was a broader issue?
Absolutely. You'd look at AWS as well to see that, and what you see is impacting other services. So do we have anything else hosted in AWS that's within those regions or within a specific region that's actually having those problems? So yeah, again, this is that looking at context. The commonality here was Grafana hosted in AWS, not AWS.
Thanks for the deep dive into the outages, Mike. Now let's turn to the overall outage trends, and it's time to look at the monthly figures. What was the final total for February?
When we look at the February numbers, we saw 1,595 total global outages. This is a 15% increase from January's 1,382 outages. This is actually consistent with what we see typically this time of year. So as we come out from a code freeze or the holiday period, we start to see these maintenance and engineering windows sort of take place. And this is what we saw here. So once you look into the details of the outages, they were reasonably short durations, but they were to that point, they were all occurring, when we look at it from a local perspective, they were occurring outside of those normal business hours for that region or for that area there. So that was the global outages. The same pattern actually was consistent across the US as well, where the US outages rose from 657 in January to 811 in February. As I said, this is consistent with what we typically see from January to February.
So that's the February roundup covered. What have we seen over the past couple of weeks?
So looking at global outages over this period, we saw a slight decline initially, and then it returned to this upward trend that we've seen sort of coming out of February into March there. I say a slight decline because it was actually 0.2%. We actually saw one less outage on the global outages themselves. And then that second week, then they started to increase again. We went from 397 to 447, which is a 13% rise. Now, the US outages themselves initially rose from 196 to 199, which is again was a 2% increase. So it's kind of slight. But then they dropped to 189 in that second week, which was a 5% decrease. If you want to look at those from a US-centric perspective, from February 17th to March the 2nd, 46% of all global outages occurred in the US. Now, this was down from 55% in the previous period. In 2024, we averaged 40% or greater for that period. So we're still maintaining that, but it's interesting to see we've actually dropped now below this 50%.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.